Okay, in this section 6, we're going to be doing systems of equations, and today we're going to do systems by graphing. But before we do that, we're just going to do a quick review of our factoring. Remember, factoring never goes away, and we got to know how to factor. So on question number 1, I noticed that it's 4 terms. So right off, in my mind, I'm thinking grouping. That would be the one that we learned that had 4 terms. So I'd group the first 2 and the last 2. And then the greatest common factor out of the first 2 terms is x squared. So that would leave me with an x minus 3. And then the greatest common factor out of the second 2 terms would be a negative 16. So I'll factor out negative 16, and that will also leave me with x minus 3. So the parentheses are identical. And so that's now my new GCF. So I'm going to factor out the x minus 3, and you're left with x squared minus 16. And x squared minus 16 is the difference of squares. That's one of our special patterns. Hopefully we're to the point now where we recognize that one right off. It goes to x plus 4 and x subtract 4. Okay, so difference of squares. Number 2, it looks like to me it's 2 terms, so I'm thinking special patterns, but before I do that, I always look for greatest common factor, and I notice those both have 3y to the third common, so I'm going to factor out a 3y to the third. And that's going to leave me with y squared minus 25. And once again, I recognize that y squared minus 25 is the difference of squares. So I'm going to go ahead and factor that to y plus 5 and y minus 5. Okay, question number 3. 2 terms again, so I'm thinking that could be one of our special patterns. Greatest common factor looks like, I'm wondering if 16 divides into 686. Let's check that first. I can tell that there's an x squared, but not sure about the other number. So let's see. 686 divided by 16. Nope, doesn't go in evenly. What else goes into 16? We got a 4 and an 8 maybe. 686 divided by 4. Nope. 686 divided by 8. Nope. So it looks like to me the greatest common factor is a 2x squared. So we're going to take out a 2x squared. And that's going to leave me with 8x to the third minus, and then 686 divided by 2 is 343. And hopefully we're recognizing that one as one of our special patterns. That looks like difference of cubes to me. 8 is a perfect cube number, x to the third is a perfect cube, and 343 is a perfect cube. 7 to the third is 343. So let's go ahead and factor that. So remember, this is the one where we have a smaller parenthesis and a bigger parenthesis. So 2x and 4x squared, and then minus 7. And this is going to be plus 49 on the end, and then the middle term is going to be plus 14x. Okay, so that's what that one factors to. And then on the right, on number 4, I noticed that, yep, 4 terms, so that makes me think grouping. I'll group the first 2 and the last 2. GCF out of the first 2 is an x squared. That leaves me with x plus 7. GCF out of the last 2 is a negative 9, so that'll be x plus 7 also. X plus 7 is now my new GCF. And so now I have x squared minus 9. And once again, that's difference of squares. So that's going to factor to x plus 3 and x minus 3. Okay, and last one. 3 terms here. It looks like they're all divisible by 4, and they all have an x squared common. So I'm going to take out a 4x squared. And that's going to leave me with x to the 4th minus 5x squared plus 6. Okay, so now we need to factor that. It's an x to the 4th, so that's going to factor to an x squared and an x squared. And factor pairs of 6 are 1 and 6 or 2 and 3. Now you could get a 5 out of both of those, but since the n number is a plus, that means I want them to add to be 5. So I'm going to do the 2 and the 3. So I'm going to go minus 2 and minus 3. Okay, so we could stop right there. You could do those as difference of squares if you wanted. That could go to x plus square root of 2 and x minus square root of 2. And x squared minus 3 could go to x plus square root of 3. and x minus square root of 3. Okay, there we go. There's our factoring. Now we're ready to move on to today's material, which is solving a system of equations. So here we go with that. Over here on the left, it looks like to me I have two equations of two lines. So we're going to have to graph those two lines and see where they intersect. All right, so the top equation looks like the y-intercept is at -8. So 1, 2, 3, 4, 5, 6, 7, 8. So here's my first point, and my slope is up 2/7. And that's this line right here. Okay, and then the second equation looks like it starts at 1, and the slope is down 1/1. Okay, so I can see that these two intersect at this point right here. So that's the solution to our problem. So that's the point. What is that? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So 7, -6. So the solution to this is 7, -6. We're looking for that intersection point. Okay, next one looks like it's two lines again. Top line, if you'll remember, is a horizontal line when it's y = 4. So we'll just go up to 4. 1, 2, 3, 4. Draw our line. And then the second line is a slanted line with a starting point, a y-intercept at -2. And then I'm going to go up 2/3, up 2/3, up 2/3. And there's our line. So, oops, I missed my point there, but you can tell that this is our intersection point. So that's 9, 4. So our solution is 9, 4. Okay, this one looks like we've got an absolute value. Remember, that's our V shape, and we've got a parabola. So the parabola is in standard form. So right now I can't graph it just by looking at it. I'm either going to have to get it into vertex form or intercept form, one of the two, to be able to graph that. Let's graph the absolute value first. So this is HK right here. So that's my starting point. So it starts that -1, -2. That's kind of like the vertex point of the V shape. So I'm going to go left 1, down 2. And the 1/2 out in front right here, this is our A. So that means I'm going to go up 1/2, up 1/2. Now I'm going to go in both directions. And remember, I'm supposed to do a V shape. So don't draw a line. Absolute values are V shapes. So I'm going to go up 1, left 2, up 1, left 2 to make that symmetric V shape. I'm going to put as many points as I can, just so that when I go to find the intersection, hopefully it'll be one of these points that I've graphed. A lot of times I try to make them intersect on a grid point, but they do not have to intersect on a grid point. In the real world, nothing works out that easy. But for us, we try to get them on grid points. Doesn't have to be that way, though. Okay, so x² - 6x + 9. That's my parabola. It's in standard form. So I think I'll do axis of symmetry to see if I can figure out what the vertex is. So our axis of symmetry is going to be the opposite of b over 2 times a. So 6 divided by 2 is 3. So that means my vertex is 3. And then remember, we take the 3 and we plug it back in. So 3² - 6 times 3 plus 9. So that's going to be 18 minus 18. So it's going to be 3, 0. Okay, so my parabola is going to start right here at 3, 0. And it's going to open up, and it's just going to follow my 1, 3, 5 pattern. So up 1 over 1, up 3 over 1. And then there we go. So the intersection point on this one is right here at 3, 0. So my solution is 3, 0. Now, back to the parabola. You could have, I did axis of symmetry to find that. Another method to graph that is you could have factored that. If you looked at x squared minus 6x plus 9, you could see that that factors to x minus 3 times x minus 3. So that tells you right there that the only point that you have on the x-axis is 3, 0. That's your vertex. And then you could have done the same thing. So I did axis of symmetry. You could have factored that to find the x-intercepts. Either way works. Okay, looks like on number 4, we've got a parabola and a line. So we'll start with the vertex of the parabola. So the vertex of the parabola is right here, our HK. So that's going to be 4, 3. So I'm going to come over here to 4, up 3. And there we go, 4, 3. And it's a -2 out in front. So it looks like to me it's going to be pointing down. And instead of doing a 1, 3, 5, 7 pattern, it's going to get stretched by 2. So I'm going to go down 2 over 1, down 6 over 1. And then we're going to be off our graph paper. So sketch that in. Okay, now we'll graph our line. It looks like it starts up here at 7. And then we're going to go down 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1. So there's an intersection point. Down 2 over 1, down 2 over 1, down 2 over 1. There's another intersection point. So this one has 2 solutions. So this one has a solution right here and right here. So what are those points? It looks like we've got the point 3, 1 is one of our solutions. And the other point, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So 6, -5. Okay. All right, the next one. Looks like, oh, there is no next one. Looks like we're done. Okay, so we're going to be graphing. So we're going to review our graphing. Just as a quick review, maybe we should go over the shapes that we've learned. So I don't think I did every shape in the notes. They may show up in your homework. So we did absolute value. So the absolute value, and you're going to see absolute value symbols on that one. And that one is the V shape. And it would look something like this. And HK is your vertex. And then A is the slant. It's basically the slope. So, but you go in both directions to make a V shape. So I think that was the first one we learned. We did our parabola. So we have our parabola. And how it's going to tell you is a parabola is because you're going to have an x squared. And that shape is our U shape. And in vertex form, remember there's 3 forms. I'll just do the vertex form. And its vertex is HK. And then A is your vertical stretch. And remember in the parabola, we have a vertical pattern of 1, 3, 5, 7. Okay, then we did the square root. Okay, and how we knew it was a square root is because we saw the square root symbol. And the shape kind of was that sideways half a parabola. So its formula was y equals a square root of x minus h plus k. And once again, I'm not going to keep writing that because a is always going to affect the vertical stretch. Um, well, actually, maybe I'll write it on this one. So a is your vertical stretch. So hk was the starting point. And then this one had not a vertical pattern of 1, 3, 5, 7 like the parabola, but it had a horizontal pattern of 1, 3, 5, 7. Okay, so that one goes horizontal 1, 3, 5, 7. Okay, and then we learned the cubed root. So cubed root, and how we knew it was a cubed root because we saw the cubed root symbol, and that shape was the sideways S, and its formula looked like this. Oops, forgot the A out in front. X minus H plus K. A, once again, is your vertical stretch. A always affects the vertical pattern. And then HK is what I call the start point, but it's kind of like the center point. We start there to do our counting, but it's kind of in the center because it's this point right here. That's your HK, that one. And this one had a horizontal pattern of 1, 7, 19. We never got to the 19. We always just did the 1 and the 7. Okay, so we had absolute value, parabola, square root, cubed root, the circle, I think was the last one we learned. So the circle, besides line was something we already knew. I didn't put line up here, but line is something we already did. So the circle, how you know it's a circle is you have to have an x squared and a y squared. That's how you know it's a circle. So here's your circle, here's your center. And so on this one, same thing. Its formula now looks like x minus h quantity squared plus y minus k quantity squared equals r squared. And so hk is the center of the circle. And r is your radius. So I think those are the main graphs that we've learned so far. So that's kind of a quick review of what we had besides the line. So remember your line. You could do the y equals mx plus b. You could also write it as x minus h plus k, where a is your slope. And then hk is any point on the line. Y equals mx plus b is just a specific case of hk where h is 0 and k is your y-intercept. That's how they get y equals mx plus b. Anyway, so that'll help you if you've forgotten how to graph those. I think those are the only ones that are going to show up in your homework. So that's what we'll be doing today. You'll be graphing and you'll be writing down all the intersection points of where your graphs intersect. And remember, they don't necessarily have to show up on a grid mark, but most of them do, but they don't always have to.